some minutes so that everyone can join. 5 to 10 minutes for that. Let's wait for some more minutes so that everyone can join. Okay, so at least one person is there, so I can start now. Okay, so today we will discuss how to use separation of variables to solve PDEs, or here's some analytic way of solving as well. So let's discuss first two types of methods to solve PDEs. Can I just go? So how to solve PD? Wait, my voice is audible now. Yeah. Okay, so there are two. One is direct integration, and other one is separation variables. Okay, so how does it work? So for example, I just start with some questions. So if I have, first of all, we will see with an ODE case. So if it is, you have an ODE like this. So you have given that y is 1, then x is 0, which means that y at 0 is 1, and dy over dx at x equals 0 is 2. Then you have to find out, or it is just y prime 0 equals to 2. Then you have to solve this ODE. So how do you solve it? It's easy, right? How do you solve it? You just, so this is the first one. So I rename it first and I just integrate it. So integrate first with respect to x on both sides. And what do you get? Dy by dx. Second order becomes first order, and x squared becomes x cubed by 3. 2x, 2 becomes 2x, and some constant a. Okay, and similarly you integrate it. Integrate second with respect to x on both sides. So that will give you y to be x4 by 12. This integration same way, and x plus ax plus b. Okay, right. So that's the kind of, we say that it is the general solution. Star. Star is the general solution. And we have to find out exact solution given the initial conditions. So what is the exact solution? That is, so you substitute y0 equals to 1 here, which gives, so if you substitute y0 equal 1 here, then in star, it gives b equals to 1, and y0, y prime 0 equals to 2 gives a equals to 2. Okay, so the required solution, whatever, is basically this one. So that is the simple way to solve an second order ordinary differential equation. So how do you solve PDE now? Okay, I just take another pen. So I just start with a PDE like this, del du u by del x square, which is same as 2x to power t. So if you have to solve this one, so how do you solve it? Okay, so similar procedure. So integrate this is first, integrate first with respect to x on both sides. So what does it give you? It will give you this del u over del x equals to x square e to the power t plus f of t. Yes. And then you integrate it again. So here you see the difference. So here the constant is function of time because it is u is a function of x and t. So the constant will be a function of time because it's partial differentiation with respect to x. So it has no dependency over t. Okay. So again again integrate second with respect to x on both sides again. Then what you're gonna get is basically u, which is x cubed over 3 e to the power t plus x ft plus so another function of time gt. So that is you get. Okay. And suppose you do have some initial conditions like u0 t equals to t and del u over del x 0 t equals to e to the power t. Then what you're gonna get is, so if you insert this over here, then you get gt is equal to t and ft is equal to e to the power t. So the solution would be u equals to x cubed by 3 e to the power t plus x e to the power t plus t. So that will be your solution of this PD. Okay. So similarly, if you can try this for this PD I just give you. So how to solve this? So question is solve the PD del 2 u over del x del y equals to sine x cos y subject to constraints. Conditions subject to conditions del u over del x to be 2x at y is equal to pi by 2 and u is equal to 2 sine y at x is equal to pi. So just try to solve this and find the solution of this. Then I will try to do it just for 5 minutes. So these are the basically the direct methods that I'm discussing now. But we will go to separation of variables as well. But first this course. Okay, just try for five minutes. Okay, so I hope you have done this, and I just go with that. Yeah. So how to solve it? So we have in this case, I just use black. So del to u over del x del y is just del over del y, del u over del x, right? I can write like this. So you have to integrate with respect to y. So integrate first. Respect to y. So what do you get? So that is del u over del x, which is same as here. If you see, this is sine x cos y. So what is the integration with respect to y of cos y, which is sine y? Yes. And there is some constant of which function of x. So now it's del u over del x. So we do have a condition which says that del u over del x is 2x at y is equal to pi by 2. So we use this. Okay, so at y is equal to pi by 2, del u over del x is just, what's that? That is 2x. So substitute it here. So you get 2x is equal to sine x plus fx. So fx is, what is the value? 2x minus sine x. Right? So del u over del x is sine x cos y, sine x sine y plus 2x minus sine x. Okay. And now you have this equation. You again integrate it. Integrate to with respect to x. So what you get is u equals to minus cos x sine y plus x square plus cos x plus gy. Yeah. So you use the initial conditions.
Hello, yes.
Yes.
Yeah, actually, question was dou to u by dou x dou y equals to sin x into sin y, right?
Where is that? Let me see.
Mr. Main question.
Yeah, in the question, what you are saying?
Okay, sin x cos y was there. Okay.
Yeah.
Actually, okay, cos y. Actually, I wrote sin x sin y. That's why. Okay.
Oh, that's one. But the approach will be same and you will get.
Mm-hmm.
Okay. There is the initial conditions again. So what are these initial conditions now? That is u equals 2 sine y at x equal pi. So we substitute at x equal pi, u is 2 sine y. Yeah. So what do you get in the last is you have to find gy. So you will get gy to be something like this, sine y plus 1 minus pi square. Because you substitute x here, u is just 2 sine y minus sine y, and that's sine y and plus 1. Okay. Yeah. So that's, so if you find gy, then yeah, you got the exact solution. That's what I'm going to focus to. Okay.
Yes, just show me once second equation. Actually, I didn't get that. Yeah, one minute.
You didn't get this, how it came? Or
Yeah.
should
One
I
minute.
explain?
Yeah, you can proceed.
Okay. I hope it's clear, this one. So these some direct methods to solve. You just integrate it and you do have initial conditions like that, and then you solve it. Okay, so next method I'm going to focus on is method of separation of variables. Okay, so in this case, I just start with some theory, something. Okay. So I just use a heat conduction equation, heat equation, L to U by del x square equals to 1 over k del U over del t. Okay, so what does methods of separation of variable look like? Is you assume that U is just a multiple of some functions, capital X and small dt. So this is a major assumption that you have to start with first. And then you just have to substitute over there in the equation. So what is del U over del X is basically del X over del X, and dt remains same. So it is capital X dash t. Okay. And what is del U over del t? That is x, you keep it out, and del t over del t. So that's just xt prime. And what is del to u by del x square? That is just the double differentiation of this. So x double dash. So I just substitute these values, these three values, star. So I just substitute these star values in the equation, say A. Okay, substitute a star in A. Okay, so next one, how do you do that after substituting? Okay, so that will be x double prime t, right? And which is same as 1 over k x t prime. And I can change it to x double prime divided by x and 1 over k t prime over t. So that's one thing. Okay, so what's the next step you have to focus on? So the left side of this equation, x double prime over x, this side, it involves function of x. So it's just a function of x. And if you see the right side expression, t prime over t, that contain functions of t only. So if you change the value of t, that cannot change the left hand side, so it stays constant, right? So right side should be constant. So in that case, you say that dt is just a function such that this thing is constant. So we just say that 1 by k t prime t is some constant k cap. So I just use another notation, I think so. Maybe q. Okay. So it's just a constant q, just renaming it like with some number, arbitrary number. And similar argument, you can say that x double prime over x is also q. So in that case, you solve it, and this becomes basically an ODE, right? Yeah. So I just want you to try one question based on that, maybe. Okay. What's that? Okay, so wait. Yeah, so you can also do similar work for wave equation. So I just write use separation. Solve this wave equation. So the equation is this, which is, okay, maybe I can give you exact question which relates it to that. Don't know. Okay, that's in general, but you try to solve it for this for the moment. C square. Just try to find an expression of ordinary differential equation in this case. So just try this 5 minutes. constant and exponent. Okay. So let's do that and one particular more question and then we will go to integral transforms. Okay, there is that. Yeah. So how you know how to solve it? Okay.
Yeah, it's easy, no problem.
Yeah. So, but in particular, if you need to find exact like specific solutions, I just do one problem, solve it myself. Okay. Which one is good? Okay, we will start with heat equation. So solve, we properly solve it. Solve the heat equation del U over del x square equals to 1 by 2 del U over del T with x between 0 to 3, T between T is greater than 0. So U0 T is U3 T is 0. So I think you know about these conditions, right? So that are called the boundary conditions. And ux0 is just 5 sine 4 pi x. That is initial condition. Okay, so what's the first step that you have to do? You have to put uxt to be capital X, capital T. I just write like this. So once you substitute it, solve it, then you just find out that dt over dt, these you arise with two ordinary differential equations that you do always in this case. One is first order, other one is second order. Okay. So what is the solution of t? Do you know that? So what is the solution? So here you just integrate it. So it's 8 something, a times e to the power 2 kt. Okay, the solution of this. And so if k is positive, then it increases exponentially and it decreases with t if k is negative. So
Actually, in exponential, e to the power 2k small t will come, right?
e to the power 2k is
2kt, that t
yeah,
will small t will come, no?
yeah.
Time.
Okay, yes, you're right. Yeah, sorry. Yeah, yes. So which case you should consider k positive or negative, whatever you like. So if k is negative, if k is negative, then you just take k to be some minus lambda square, something like that. Then you have t is a e to the power minus 2 lambda square t. Okay. So once you substitute k like this, then x in this equation, you can also solve it. So what's the solution of this equation if you know this? So that's also you know, right? So x is p cos lambda x plus c sine lambda x. So it's useful because you can remove the square root and take this over here. So you know x, you know t now. So what is uxt now? Uxt is just capital Xx, capital TT, which is d cos lambda x plus e sine lambda x, and something with t, which is e to the power minus 2 lambda square t. Okay. So that's called as general solution. How do you find the specific solution, particular solution in this case? So you do have general solution. Now you try to do, okay, where D is AB and E is AC. Okay. So what are the initial conditions here? You now use them, right? So U0 to t equals 0 and U3t is equal to 0. So U0t is equal to 0 and U3t is equal to 0. So U0t equals to 0 gives you this d equals to 0. So if you check this, then it implies d equals 0 and U3t equals to 0 gives you e times sine 3 lambda e to the power minus 2 lambda square t is equal to 0. Okay, so you cannot say that e is 0 because then your solution 11 would be, so where is the solution? That's the general, yeah, so this general solution would be 0 in this case, because if e is 0, wait, then it is just t cos lambda x and d is already 0. So if e is 0, then uxt is 0, but you don't want uxt to be 0, right? So you want e to be non-zero. Then it implies that this implies that sine 3 lambda is 0 as e is non-zero. Okay, so sine 3 lambda is 0 implies that 3 lambda is n pi. Lambda is n pi by 3. All right. So you know lambda now, so you know what is uxt now. So uxt is just something, okay. So lambda is n pi by 3, and what is e in this case? What does you get? E is a times c. What is this? K is something like this, minus lambda square. Okay. Okay, so what is uxt now? That is this one, e sine lambda x and e to the power minus 2 lambda square t. So you just substitute the value of lambda here, and e is just the constant one. So uxt is en because it's dependent on n, and sine n pi x over 3 e to the power minus 2 pi square n square t over 9. Okay, so that's uxt now. Now you have to use initial condition. Ux0 equals to 5 sine 4 pi x. Okay. So what is the, so you just substitute it here and find out that ux0, if you substitute it here, then it's just en sine n pi x over 3 equals to 5 sine 4 pi x. So what value of n you should choose such that en is 5? Find n such that en is 5, or n pi n by 3 is 4. So n is 12. So it is just E12. So you just take, so uxt is just 5 times sine 12 by x by 3 e to the power minus 2 by 9, 12 square by square t. So that's it, 4 pi x and e to the power minus 32 pi square t. Is that clear? How do we arrive at the final solution?
Yeah, yeah.
Okay. All right. So we have done this a bit on separation of variables. You can try doing more exercises based on different types of initial conditions or so. I think it would be not so difficult. Just follow the steps. Okay. Okay, so now next thing is solving PD. So I think the Laplace transforms have already been discussed in your lectures, but I will just do some questions. Laplace transforms. Okay. So what is a Laplace transform, if you remember? Okay. So if you have a function, so given a function uxt t greater than 0, and you assume that uxt is bounded so lxt is this is luxt is this. So that's the Laplace transform L of uxt is integration of 0 to infinity, integration from 0 to infinity e to the power minus st uxt dt, which is same as capital Uxx. So it's just an integration with respect to t, right? Right. Okay. So what is the Laplace transform of utxt? Can you tell me? So you just have this one with utxt. Ut, you know, right? Partial derivative with respect to t. So you just use integration by parts and say that this is just uxt from 0 to infinity plus s times integration 0 to infinity minus st uxt dt. Okay. So that is su capital Uxs minus small ux0. That is L of utxt and suxs minus ux0. Okay. So what is the Laplace transform of, so this is the Laplace transform of lutxt. Yeah. And what is the Laplace transform of utt xt? Double derivative, double partial derivative of u with respect to t. That is uxs minus su as capital ux0. Wait, that's not this case here. So that's a small u actually, and utxt. Wait, I think that's capital U, that's small u, so that's small u. Sux0 minus utxc. So similar to the ordinary derivatives you're getting here. Yes, that's what I want to say. And what is the Laplace transform of u partial derivative with respect to x? So it's just ux, right? And Laplace transform of u is one partial derivative of x with respect to. So that is just u capital xxxx, right? Okay, so that's easier, right? So just try to find out How do you solve it using a Laplace transform? Just give it a go for some minutes. I just write one question, how to solve a PD. So solve the PD, del u over del x plus del u over del t is equal to x greater than 0, t greater than 0, and u0t is 0, t greater than 0, and ux0 equals to 0, greater than 0, using Laplace transforms. Okay, just try and find the solution and we will discuss that. Okay. Okay, so I think you have done this now. All right, let's discuss now this one. So how do you solve it? Using Laplace transform? So I haven't told. So I just told you how to take the Laplace transform, not the inverse. So what is Laplace transform? How do you start with? So uxx is the Laplace transform of u small uxt over s. And then you apply the last Laplace transform. So let's take the first equation, apply Laplace transform. So what do you get? You just use the same things. So once you get this, then you get du dx xs plus xx minus ux0 is equal to x by s, which implies du over dx plus su equals to x over s. So how do you solve it? So this is a constant, this is a linear ODE, right? So you just use integrating factor. Integrating factor. What is integrating? Mu is equal to integration of e to the power s dx, which is e to the power sx. Okay. So what is now happening here? Things. So you just u into integrating a factor, y into I is equal to integration q into I f dx. So x over x e to the power sx dx. That's what you find, how you find the solution using integrating factor, right? So ultimately you can end up with this type of solution. And then you just have, what do you get at last? Okay, so you can use integration by parts over, use integration by parts to solve this integration. And then you find out that uxx is something like this. Ultimately, like I'm writing the final solution, you can find it. And then you can evaluate C using boundary conditions. So what is u0s? Which is minus 1 by s cubed plus c. And u0s, capital U0s. What is capital U0s? That is Laplace transform of this is 0, so you just take 0. So uxx is just x by s square minus 1 by s cubed plus e to the power minus sx by s cubed. Okay, so this is your capital uxx. Now find inverse. What happened to my pen? Hey, stopped. Okay, my pen is not working. I just, okay, so I would suggest just try to find the inverse Laplace transform. I just write here. Find the inverse Laplace transform of the above equation for now. Okay, just try to find that. Yeah. What do you get after that? Yes. What do you get? Yeah, I think it's now works. Okay, so you got you. Okay, so you got you. Why it's not working? I think its charging is not finished or what? Okay, like it's not working on the pan. It's not working. I just write in another page. Okay. On this page, it's not working, but on this page, it's working. Why is that? Okay, so UXX is this. Then after finding inverse Laplace transform, you get, oh, I green, small uxt. So small uxt is what? What you get? So what is the inverse Laplace transform of x by s square, 1 by s cube, and this one? So I just write it as this. Xt minus t squared by 2 plus h of t minus x, t minus x whole square by, and where h is heave side function, heave side. So ht hx is just less than equal to 0 and x, sorry, x is greater than equal to 0 and x, right? Just remember there is a table you can find out from anywhere to just learn the Laplace transform of the functions and the inverse. Just try to learn that. It will be very helpful. Okay, so that's about Laplace transforms. I just go with Fourier transform then. So how to solve PT using a Fourier transform? Okay, let's go with that. So I just take wave equation del 2u by del t square z square del 2u over del x square, right? So what is the Fourier transform? So I just write here Fourier transform denoted by u cap kt. Instead of s, you just use k here. Minus infinity to infinity. So instead here is the twist is you start from minus infinity, you end up with infinity. Minus ikx. So you want your domain to be like this. Okay. Okay. So what is the Fourier transform of a derivative of function? So, okay. I just tried something here. So what you can do is try to calculate the Fourier transform of utxt. So what is it? So that is ut hat. Yes. So you can write ut as, so I would say that it's just partial derivative of u capital K hat u hat kt. Yeah, you can just check it. And similarly, you just try to check what is uxx hat. Sorry, utt hat kt. So what is this? Okay. So I just write it again here, and UTT XT K IKX dx. So what is that? That's also the partial derivative with respect to, and you had kt. So del t2 you had kt is just minus c square k square u had kt. Okay. So how do you solve it now? So you take u hat kt is equal to capital U t. So that will become kind of ordinary differential equation again. K square ut equals to 0. So now you can find the solutions. Just find solution of this OD. Okay. So once you get the solutions of this OD like this, say ut is something like d1 plus d2t, then you can just, okay, so what is u hat in that case? Okay, depends on which type of solution you do have. Okay, so you can just substitute what is capital UT, that is u hat kt, and you invert it. So if you have to invert it, then you use uxt is just by inverse Fourier transform. So that's just 1 over 2 pi minus infinity to infinity u hat kt ikxt. So just try to change it this way, and this is basically, so it depends what is u hat kt in this case, and depending on that just try to change it. Yeah, so you substitute there and you find it what is uxt, that will give you exact solution. This is like this, and you can try many problems on this as well, depending on your lecture notes. Okay, just solve as many problems as you want on this. So that's all for today, and we will discuss numerical schemes, numerical methods for solving PDEs next time. Okay. Now, if you have any doubts, you can ask.
Yeah, regarding the assignment, have you gone through the assignment?
I haven't got the assignment yet. Like I cannot see what's in the assignment.
Okay,
I
okay.
asked them,
Actually,
maybe they soon for,
mhm.
yeah.
Yeah, actually, one question that I asked through mail also, that in one question means two parameters has been asked, but the space is like means I can answer only one because comma and two decimals are not allowed in that space.
Yeah. Then the NPTEL team can help in that case, I would suggest. Do you have the email of them?
Yeah, yeah. Actually, parallelly means I asked you also and the TA of the course also. So that side, from that side, I got reply that it's better to answer the second parameter, means the molar velocity of ammonia.
Okay. Yeah. I would
Because
say
tomorrow,
just go with because the TA
Because
is
tomorrow
free.
is the last day.
Okay. Have you done all the questions then?
Yeah, I have done all the question, but just
Okay.
I thought means if suppose you would have the questions, then we would have discussed it once.
I don't have. Maybe I will have to again write an email because they haven't replied.
Okay, so Miss, as per the T of the course, she has asked to answer the second parameter. So should I go with her only?
Yeah, yeah, because most of the cases your TA may be framing the assignments, so he knows.
Okay.
Yeah,
Mhm. So it means next session also will be on the Tuesday, next Tuesday.
yeah, yeah. Next Tuesday. And I haven't posted, I think, the recording of this session yet, right? So I will post it soon today by itself. Last session as well.
Okay, Miss. Actually, Miss, I was trying to open. Actually, one sheet was getting opened, but that sheet, Excel sheet was blank.
Okay. Yeah, yeah, yeah. I will do that just again. Haven't posted. I was busy last week. I will do that.
Mhm. Okay. And try it. Suppose you have the access for the assignments, then
Okay.
we would discuss if
So
suppose
the
any
assignment,
assignments problem will be.
how are the questions in the assignment too? Are they difficult or the similar material I've discussed today?
And actually, Miss, assignment is exactly not that we are discussing.
Okay.
Mm. That's why I
Assignment
thought
is
if
not
suppose
the your lectures, you are saying, right?
it is much related to the lectures only. And
Okay.
there also means question is asking in some other way. Means if suppose sir has given one example in which he has taken one case, then the question is being asked for the second case, means some other case. So that has
Okay.
to be again I have to solve it. So just if suppose I have some doubts, then I would have some discussion with you and we'll have
Yeah.
clarity about all this. That's why I'm telling about the assignments. Suppose you would have access about that,
And
then it would
my
be
first time this time to teach this course. I don't know, like in my past courses, they have shared me the assignments, but I don't
okay.
know
Okay.
about this. Like, I will have to ask again now. Maybe I will email professor. I will do
Mm.
something.
Because in the last class we have studied parabolic PD with cylindrical coordinates,
Okay.
Bessel's functions, and all those. And assignment was also related with all those things.
Okay. But do they have
Mm.
questions on these methods that I've discussed?
Uh, Means they didn't ask exactly the all these things.
Okay.
Actually, Miss, what you are teaching is small part of the second week course or first week course. Actually, that course is very depth and so many things sir is discussing.
Okay. Then I have to look
Like
at next time.
that's why suppose you will go
Because
through
I
the
don't have any
week.
idea and I will do that. Whatever I can. Mm.
Because if suppose you will once have an idea about the week,
Yeah,
particular week, what are the courses that has been taught, then
yeah.
according to that only questions will be asked in the assignment. So if suppose you will have that access also, then you will come to know that so many things. Whereas
Okay. Mm.
actually, means today you have taught means Laplace and Fourier. So that was only the last class out of six classes, five
Yeah.
or six classes. That is the last class only. Other four classes, it is entirely different thing.
And separation of variables is discussed, no?
Separation of variable is there, but that's what I'm telling. That is very small part. After that,
Okay. Mainly they focused
Bessel's
on the
functions.
Chapter and Bessel functions.
Bessel's functions sir has discussed.
Okay.
Then one Newman, three cases were there. One Newman and Dirichlet and mixed
Okay, the
forms.
boundary conditions you are talking about. Okay.
So all those three cases, sir had extensively discussed about the
So he's also
originality
doing
function
some
also.
problems, right?
Means from there only we have got questions in the assignment.
Okay. So your assignments are just directly from your lectures, right?
Not from lectures. That's what I'm telling. If suppose the sir has uh, asked, if suppose one case was there in which sin x cos x was there, but in the question it has been reversed. So again, we have to go with the solution from the initial part. And
Okay, means quite related to what he is discussing, like giving some
it
homework
is related only.
exercises. Okay.
Yeah, it is related only. But
Maybe then I will see just
actually,
the lectures of sir and I will closely relate them to their whatever teaching.
that's what because if suppose the sir has
And do you know
whatever
which
sir
book you are following for that?
uh, as of now, I'm not following any book. I'm just following sir's lectures. And if suppose I have any doubt, then I used to Google it.
Okay.
Actually, the main thing is like that only. Uh, if suppose
Mm.
sir has whatever sir is teaching, it is okay, no problem. But the assignment, those direct questions are not coming. With so many uh, changes are there. So if suppose
But
all
they are
those,
easy, right? Or tough.
no, it is tough.
Okay.
So if suppose I will go on solving anywhere,
Mm.
any step, if suppose I have some doubts, then miss I can't have any access to ask directly to sir. So in that case, it will be you only from whom I can clear my doubt.
Yeah, I just try to frame questions based on the lectures mainly and the homework exercises he gives.
That's why if suppose you have access of for week course
Yeah,
also and assignment also. So if suppose any problem in the assignment, then we can have.
I don't have
Uh,
access to assignments, but I will write again then.
Miss, last time, do you have access?
No, no, no.
Okay, and
Um,
about the course lectures.
yeah, yeah, lectures I do have.
Okay, so if suppose through lectures also, because question assignment will be asked from lectures also. So if suppose you would have some idea that okay, this week these lectures have been discussed, then I will solve the assignments, and if suppose any doubts will be there, then I can get clarity from you.
Okay, yeah.
Like one question was there.
Mhm.
If suppose means which of the following is a closed system? Okay, so one
Yeah.
option was there, pressure cooker.
Hmm.
So pressure cooker, if suppose we are dealing with in the normal case, then it will be considered as a closed system. But if suppose
Yeah.
we take that pressure cooker at higher temperature, means while cooking anything, then in that case the mass inside the cooker will come out. So that will not be considered as a closed system,
Yes.
right? So
Yeah.
means that was the means. A doubt was with me that should I consider cooking means pressure cooker at the normal condition, or should I consider that case also?
Okay. Like
Means are
these
you getting
questions.
me?
Yeah, yeah, yeah.
Actually, Miss, sir has asked one question that which of the following system can be considered as closed system. In that, one pressure cooker option was
So
also
you are
there,
trying to see
but
like how he's framing questions, like not exactly the same, but a bit twisted.
no, like in lecture, sir has discussed what is the closed system, and one or two
Right.
examples sir has
Yeah.
discussed. But those questions are asked, and the main problem is that those are multiple choices. So from four, two can be also there, three can be also there.
Okay. Dot multiple
That is the
selecting.
problem. In some questions, suppose multiple questions are there, then in that case, we can select any. 2, 3, anything like that. No problem in that.
Okay.
So
Yeah, you
with
have to
all
think
those,
about that.
so such doubts are there. Like means what should I consider? What should I not consider in any numerical problem is there.
Mhm.
Mm. So that's why I means my humble request. If suppose you get access to the course also, then just once see it, and if suppose anything
Okay,
doubt is
that
there,
would be
then
good. Like if
I
you
will
have
ask
any
you.
doubts in your lectures, then we can discuss that as well.
That's why.
Yeah.
Because here means
I will
so many
ask
things
next
are there.
time, like in this
Uh,
lecture, which problem you faced and which step you don't get in, like this.
yeah, that's why. That's why.
That would be good.
Because one question was also asked in which four options were there, and they have asked that what type of means those equations are there: parabolic, elliptic, and hyperbolic,
Mhm.
like that. So
Yeah.
that was also means two equations has been asked, and then means this type of I have solved it, but some confusion was there. So that's why. If suppose you would have material, then you could have also touched, okay, parabolic, elliptic, and hyperbolic. You would have also got it. Then I would have asked you directly that here I have some doubt.
So I don't give the correct answer to assignment. Maybe if I get the assignment, then I
No,
just
no, no,
I
no, not about the assignment. Means that I will that I will solve because that is our job. No problem.
Mhm.
But actually, if suppose that condition has been given that parabolic, elliptic, hyperbolic b square
Yeah,
minus 4ac is the value determines it. But if suppose in some cases are there where I'm not getting what is the b or something, then in
yeah.
that case would be benefit if suppose you would help me in some.
Okay, I will see that then. Yeah, next time.
Okay, then thank you.
Yeah,
Okay, thank you very much.
thanks.